Okay, today's lesson will be 8.5, adding and subtracting rationals. So we're going to be adding and subtracting these fractions we've been working with. So we need to have a common denominator. You will have a few problems in your assignment that already have a common denominator, but today I'm going to focus on doing examples that do not, because those are more challenging. So in order to find the common denominator, we'll need to find the least common multiple. Or LCM. All right, to do that, you will need to factor the expressions completely. Then the LCM is the product of the prime factors each raised to the greatest power that occurs in any of the expressions. Okay, very wordy kind of math definition here. Well, let's take a look at a few examples and make sense of what that is talking about. So if I'm asking you to find the least common multiple, and my expressions are 2x plus 4 and x squared minus x minus 6. Okay, so it's suggested that we factor any expressions that we can. So on this first expression for 2x plus 4, I can factor out a 2. And for this second expression, I can factor it into two binomials, so x and x. What multiplies to negative 6 but would combine to a negative 1 would be negative 3 and positive 2. And so then my least common multiple is the product. So I'm multiplying together all of the prime factors. So in this case, every different factor would be a prime factor, and it would be raised to the greatest power that occurs in any of the expressions. There are no problems in here that have anything with exponents, so we don't need to worry about that part. But my least common multiple will include every different prime factor. So 2 is a prime factor. X plus 2 is a prime factor. So I've taken everything from that first expression. And then I've got x minus 3. And I already have x plus 2, so I do not need to put it again because I need all of the different prime factors in any of the expressions. So I do not need to repeat it. And this would be my least common multiple. Okay, let's try another one. I'm going to put it over here. And I've got 12x squared y and 18xy cubed. So here, I cannot factor these expressions. Okay, so that part I don't need to worry about, but I need to find the product of the prime factors, each raised to the greatest power. So there's a couple different ways to do this. If you go back to, I don't know, whenever you learn this, middle school, you can certainly make a list. So 12 is a multiple of 12. 12 times 2 is 24. 12 times 3 is 36. And then you try to find that multiple that matches. So if I did multiples of 18, 18 is a multiple, 18 times 2, so 36 would be the least common multiple between 12 and 18. All right, that's one way you were probably taught, so that's totally fine. You can go with that. You could also, if you go off of the prime factors, you can do a prime factorization. And so 4 times 3, 2 times 2. So 12's prime factorization would be 2 squared times 3. 18's prime factorization would be 3 squared times 2. So if I go off of the definition, I need the product of all the prime factors, each raised to the greatest power. So one of my prime factors is 2. 2 is in both, but I need the one to the greatest power. The next prime factor is 3. 3 is in both, but I need the one raised to the greatest power. So if I take 4 times 9, that's 36. Okay, so however you want to come up with it, you can do prime factorization and go off of the definition, go for it. Some of you are going to get this answer way faster just by kind of logically thinking it through than doing your prime factorization, but it would work every time if you got stuck or if you worked with a number that was, you know, more difficult to list out. Okay, so then my least common multiple would be 36. I also have to take a look at my variables. So I have x squared and an x. The variable of x will be a separate prime factor, but I need it to the greatest power. I have y and I have y to the third, so y would be a separate prime factor, but I need it to the greatest power. And that would be finding the least common multiple. So you'll have some problems where that's all you'll have to do, and then you'll have problems where you'll need to add and subtract. So we're going to get to that. So let's start and we'll add the rational expressions. And also state the restrictions on your variables, just like we did in 8.4. All right, so my first problem, I have x over x minus 1 plus 2x minus 1 over x squared minus 3x plus 2. Okay, so when I look at these, they do not have the same denominator, so I will not be able to add them just yet. So that means I need to find the least common multiple of my denominators. So that means I must factor and find all those prime factors. When I look at x minus 1, there's nothing I can do with x minus 1, but I can factor this expression. So that would factor x and x, 2 negatives, so 2 and 1. Okay, so when I'm finding that least common multiple, I need to include every different prime factor in both sets. So on the left, I have x minus 1, and I also have that on the right, so I've already included that. I need every different prime factor, but I will also need x minus 2. So this is the denominator that I want. That's what they both need to be to match. Now I already have that denominator on the right, so I don't need to do anything with that. Just like if I was adding 1/2 plus 1/4. My common denominator is 4. I would not have to do anything to that fraction to change that denominator because it's the denominator that I want. The least common multiple between 2 and 4 is 4. So think back to that. What do I do then so that they become the same denominator? Well, I'd have to multiply this by 2 so that it would become a 4, and I'd have to multiply the top by 2. Okay, so that means I must multiply this denominator by x minus 2, because that's what it needs so that they would be matching denominators, just like I did with 2 times 2. But if I multiply the bottom by x minus 2, I must also multiply the top by x minus 2. Okay, so now what I've got is x times x minus 2 over x minus 2 times x minus 1 plus 2x minus 1 over x minus 1 times x minus 2. Notice I kept it in the factored form. I don't really want to use that form for my denominator. It's not helpful in these problems. Okay, so we want it in that factored form. Now once you have the same denominators, let's go back to our simple problem here. So 2/4 plus 1/4. I keep the denominators the same and I add across the top. So this would give me 3/4. Okay, and that's what I'm going to need to do up top. So on the bottom, I will have x minus 2 times x minus 1. And I'm putting x times x minus 2 plus 2x minus 1 in the numerator. And I want to add these together. Now I can't add these the way they are right now. I want to combine my like terms, but I can't do that until I distribute across the top. Okay. I will also have students that will really want to cross out the x minus 2 and this x minus 2, but I cannot do that if it was just written as this. Sure, I can cross those out because that is all multiplication. I am adding, so I need to add everything together. I am not trying to get rid of everything right now. Okay. So then this will be x squared minus 2x. And then if I combine my like terms there, I've got x squared, negative 2x and positive 2x would cancel out. And then I still have that minus 1. All right, so I've basically done what I wanted to do. I added the problems together that I needed to add together, and I have that common denominator. So once I'm done with the addition part, I need to double check. Could I simplify this anymore? So if I went off of the 8.4 section and said, simplify this problem, what would you do? Well, you would factor the top into x plus 1 times x minus 1. My denominator is already factored. And then you would divide out any common factors. So then my final answer is x plus 1 over x minus 2. And then my restrictions for x would not equal 2 and 1. Those are the two values of x that would make your denominator 0 at any point from the original problem to the end. Let's look at another one. So x plus 1 over 2x minus 2 plus negative 2 over x squared minus x. So if we are adding, we need a common denominator. To find a common denominator, I must factor. I can factor out a 2. I don't want this form anymore, I want the factored form, and I can factor out an x. So when I'm looking for that common denominator, I want both of my denominators to match. So that means I need to have every different prime factor. So I've got a 2, and I have x minus 1. I've got an x, and I've already included my x minus 1. So here's the matching denominator, 2 times the quantity x minus 1. I need that in both of my denominators. So take a look. What do I need to multiply this by so that it would match my denominator? Well, I'd have to multiply it by x, which means I must multiply the top by x. What do I need to multiply this denominator by so that it matches my common denominator? Well, it needs a 2. So I will multiply it by 2 and the top by 2. So let's rewrite what we got. So I have x times x plus 1 over 2x times x minus 1 plus negative 4, because I've taken my 2 times negative 2, over the 2x times x minus 1. My denominators are the same, so I will keep that same denominator. And now I'm trying to add across the top. In order to be able to add x times the quantity x plus 1 plus negative 4, I will need to distribute this so that it's x squared plus x. So I've got x squared plus x plus a negative 4 is just minus 4. So I've combined all my like terms. I've added everything that I could. So I've done the addition part. The last part would be to double check, could I still simplify this down, because I've already done the adding part. Do not simplify before you add. Okay. So I need to double check, could I factor this top? So what multiplies to negative 4 but would combine to a 1x? We would only have 4 and 1 wouldn't work, and 2 and 2 wouldn't work. So it is not factorable. So that means I will not be able to simplify any further. Okay, and then my restrictions on what x could never equal. I go back and look at every denominator that I've got. The denominators all match. So if 2 times 0 would make my denominator 0, I can't have that. And then 1 minus 1 would make my denominator 0. Okay. All right, I want to look at subtracting. So let's subtract the rational expressions. Okay, it's really not a lot different. Our first problem will have x plus 3 over x minus 2 minus 6x minus 7 over x squared minus 3x plus 2. So I need a common denominator again. I can't factor that anymore. I can factor this. And so to find that least common multiple or that least common denominator, it would need to be x minus 2 is in both, but also x minus 1. So that means my fraction denominator on the right has the denominator that I want, but the fraction on the left does not. I must multiply it by x minus 1. Okay, if I rewrite that, x plus 3 times x minus 1 over my denominator x minus 2 times x minus 1 minus 6x minus 7 over x minus 2 times x minus 1. All right, so I keep my denominators the same. X minus 2 times x minus 1. Up on top, I need to subtract. So if I'm trying to subtract that part right there, I'm going to need to distribute out the top. So I got to take my x squared minus x plus 3x and minus 3. So I've got x squared plus 2x minus 3. And here's what you need to be careful about. I'm subtracting that entire, or every term over there. So I'm subtracting 6x. Many students will do that, but I am also subtracting the negative 7. Or I need to remember to use parentheses. When I'm adding, it's not going to matter. I just add whatever I've got. But if I subtract, it's going to change the sign on every term that I'm subtracting. Okay? So that is the only thing that you'll have to pay attention to, which makes subtraction slightly more difficult than addition, but not much. So then I've got x squared. I've got 2x minus 6x is a negative 4x. And I've got negative 3 plus 7 would be a positive 4 over my common denominator. Okay, I have subtracted. I did everything I needed to do with my common denominator. Now I need to double check, could I simplify this? So let's try to factor the top and see if there's any common factors at the bottom. So this could be 2 and 2. So I do have common factors in the top and bottom. So my final answer is x minus 2 over x minus 1. Then my restrictions on my variable x would be 2 and 1. 2 minus 2 would give me 0. 1 minus 1 would give me 0. Okay, I'm going to go ahead and do one more. So I'm just going to subtract again. If that all made sense and you want to be done with the video, go for it. If you need to see another example, here you go. If you want to write it down, pause it, try it on your own. go for it. So I have x minus 1 over 3x plus 15 minus x plus 3 over x squared plus 6x plus 5. So let's factor. I can factor out of 3. This would factor into x plus 5 times x plus 1. So that means the least common multiple must have a 3, must have an x plus 5. We already got the x plus 5, and it must have an x plus 1. That's what I need in my denominator. So now I look at, well, this denominator needs the x plus 1. So that's what we need on top. This denominator needs a 3. So I'll multiply by 3. Now I'll rewrite it. Got x minus 1 times x plus 1 over 3 times the quantity x plus 5 times the quantity x plus 1 minus 3 times the quantity x plus 3 over 3 times x plus 5 times x plus 1. Okay, we've got the same denominator, so that will be, what is that? On the bottom. Okay, up on top, I'm going to need to distribute out that. So I've got x squared minus x plus x minus 1, and I'm subtracting, so negative 3 times x is a negative 3x, and a negative 3 times 3 would be negative 9. Combining these like terms, I've got x squared, those cancel out, minus 3x, and negative 1 minus 9 would be negative 10. So I've subtracted. Now I must double check. Could I factor the top and simplify? So multiplying to 10 could be 2 and 5. And then we need a negative 5 and a positive 2. And then I've got so from here, I could not factor anything else. I cannot cross out any common factors. So technically, both of these are correct. This is correct, and so is the factored form. And then x would not equal, negative 5 would make that 0, and negative 1 would make that 0. All right, that is our lesson on 8.5. Please let me know if you need help with any of your homework.